Welcome back. In the last video, we learnt about logistic regression. In today's video, let's solve a case study by applying logistic regression using SPSS. The case scenario goes like this. Graphics Private Limited is a computer animation company. The company specializes in making animation programs for media companies. The employees are required to sit long hours and use all their creativity to do their work. With the Industry 5.0 revolution, the company is experiencing unprecedented growth and it is sweating its assets to keep pace with the demands of its customers. The industry employs the knowledge worker whose skills, competencies, and attitude comprise the intellectual capital of the organization. With increased globalization, talent mobility has increased, and graphics today is struggling to cope with the loss of talent. Increased employment opportunities, skill demand, and the competitors' luring tactics all are contributing to employee turnover. The increasing employee resignations at the company are having costly outcomes for the organization. In this scenario, the company asked the HR department to understand the main reasons why employees are resigning. The CEO asked the HR department to come up with a model to predict the intent to resign. Such a model will identify the intent of resigning from the job, and the company can take proactive measures to reverse the decision, particularly in the case of performing employees. Let's revisit the basic equations of logistic regression before we proceed. You will be able to recall these equations from the previous video. In this study, the dependent or the response variable is resignation of the employees, which is a binary variable where the probability of employee resigning is the reference category and coded as 0. The target category is employee not resigning and coded as 1. 5 predictors impacting the resignation decision of the employees were identified as employee engagement, perceived organizational support (POS), tenure with the current organization, salary, and absenteeism. Let's run this case study using the SPSS software. So the data that was collected by the HR department is compiled in this SPSS data file. What you can see on your screen is the variable view. So here, if you can notice, resign, which is our dependent variable, is measured at the nominal level, and the 5 predictors, namely employee engagement, POS, that is perceived organizational support, absenteeism, salary, and tenure, they have all been measured on the scale level. Let us switch to the data view. So this is the data view. I want to draw your attention to the dependent variable resign here, which you can see is either entered as 0 or 1. So 0 over here represents the employee has resigned, whereas 1 over here represents employee has not resigned. In order to run the logistic regression, we will go to Analyze from the main menu. We'll select Regression, and then we will select Binary Logistic. Since resign is the dependent variable, we will transfer this to the dependent box, and engagement scores, POS, absenteeism, salary, tenure, they are all the predictors which have been measured at the scale level. We will transfer this to the covariate box here. We can also go to Options and click at the classification plots. Select Continue and let us select OK. Before that, also note that the method for entering the predictors, so we have used over here the enter method. We'll click on OK. So this is the output of the logistic regression that you get. The first box is the case processing summary, where the sample size is 429 and there are no missing cases. The next box is an important box which talks about the dependent variable, which is resign, and coded as 0. Not resign has been coded as 1. Then we have block 0, which is the beginning block over here. So in the data that we are using, 202 cases are there for resign and 227 cases are there for not resign. If we scroll down and we move to block 1 here, and we have used the enter method for entering the predictors, so we get the omnibus test of model coefficients as the first over here. We also have the model summary where we are getting -2 log likelihood, Cox and Snell R square, and Nagelkerke R square. We'll talk about each of this in detail. This is followed by the classification table here. If you notice, the total cases for resign were 202, which we can note from the table above. And out of those 202 cases, our model has been able to correctly predict 182 cases as resign cases, whereas 20 cases were misclassified. And therefore, the percentage of correctness that we get is 90.1. Likewise, for not resign, 15 cases were misclassified and 212 were correctly specified, which gives a percentage correctness of 93.4. The overall percentage comes to 91.9. Then the box that we have is the variables in the equations. So here we will focus our attention on the beta coefficients, which we'll be discussing shortly. And finally, we have the chart which tells us how the classification has happened. We'll now go back and discuss each of these tables, each of these important tables in detail. Omnibus test of model coefficients. This test whether a model including the full set of predictors is a significant improvement in fit over the null, that is the intercept only model. The results shown here indicate that the model fits the data significantly better than a null model. The model summary. This contains the -2 log likelihood and 2 pseudo R-square measures. The pseudo R-squares, that is Cox-Snell index, and Nagelkerke are interpreted as analogous to R-square. Cox and Snell R-square is 60.6% and Nagelkerke is 80.8%, indicating a good model fit. The classification table provides the frequencies and percentages reflecting the degree to which the model correctly and incorrectly predicts category membership on the dependent variable. As you can see, the specificity of the model is 90%. The sensitivity of the model is 93%. The accuracy of the model is 91.8%. Variables in the equation. The beta column contains the regression coefficients. For each predictor, the regression slope is the predicted change in the log odds, that is, logit of falling into the target group as compared to the reference group on the dependent variable for per 1 unit increase on the predictor while you are controlling the remaining predictors. In this case, the target category is represented by 1, that is, not resign. Using this logic and referring to the variables in the equation, we can say it was found if employees had a higher work engagement level, they were less likely to resign. Note, the beta here is greater than 0. That is, as employee engagement increases, it increases the logit or the log of odds, that is log of ratio of probability of employee not resigning to resigning. The beta coefficients for POS is also greater than 0, implying as POS increased, the logit also increased. If the employees believed the organization supports them, they were less likely to resign. Using the same logic, we can say, having spent more time in the organization and higher salaries also predicted higher log odds, that is, log of ratio of probability of employee not resigning to resigning. The beta coefficient for absenteeism is less than 0. It stands at minus 0.210, implying as absenteeism increased, the log odds decreased. Employees exhibiting higher absenteeism was a warning bell for the organization. An intervention was warranted to arrest the intent to resign. The chart, this shows the classification of categories in a visual map. The left side is resigned. If you remember, we coded it as 0, and the right is not resigned, coded as 1. You can see there are very few misqualifications in this chart. Based on the result of running the logistic regression, the HR department made the following recommendations. The study reveals factors like employee engagement, POS, salary, tenure, and absenteeism as a leading indicator of resignation. And organizations can take preemptive measures to reverse the decision. Noting that tenure is having a significant impact on intent to resign, work on promoting engagement rights right from the beginning in new hires. Perceived organization support and strategies to boost employee engagement can help organizations to bring down resignation rates. By appreciating the employees for their work and involving them to participate in decision-making leads to higher work engagement. Monetary benefits are important motivational factors to employees as they guarantee physiological and security needs. Therefore, compensation strategies should be designed keeping internal and external equity in mind. This can help the organization to win the war for talent. With this learning, you will now be adept in applying logistic regression to solving real-world issues. Well, all good things must come to an end. We have come to the end of our course on HR analytics. As we conclude this enriching 6 weeks journey into HR analytics, we have equipped ourselves with tools and insights to make data-driven decisions that truly transform workplaces. Remember, the power of analytics lies not just in the numbers, but in the stories they tell and the actions they inspire. Let's take this knowledge forward to build more engaged, inclusive, and high-performing organizations. Let's keep honing the analytical mindset and skill set. On a lighter note, remember what Ronald Coase said, if you torture the data long enough, it usually confesses. Thank you for your dedication, curiosity, and enthusiasm. Here's to applying what we have learned to shape the future of HR.